In this video, we're going to take a look at how to plot an exact graph. In the previous unit, we took a look at linear equations, quadratic equations, cubic equations, and absolute value equations. And we kind of looked at the equation to predict what the graph would look like. But we didn't actually graph exact points. In this video, I'm going to show you how to plot the exact points that fall on the graph to see if our predictions come true. Woohoo! All right, so a couple of hints from the previous unit. All right, remember that f of 2 means that we're going to take that 2 and plug it into every x in f of x. So for instance, if I had the function f of x equals 3x plus 1, I would take the 2, so f of 2, and plug it in everywhere I see an x in the equation. So remember, this would mean multiplication, and then we use order of operations. 3 times 2 is 6, and 6 plus 1 is 7. So f of 2 would equal 7. We learned that a while back with function notation. So also, taking a look now with PEMDAS, if you remember order of operations, this really is important in working through this hint, okay? So if we had a situation like this, and this is something that we will see often, all right, we're plugging in the -2 everywhere we see an x in h of x. Now, notice, first things first, we always have to take care of what's inside the parentheses, all right? So we would simplify -2 minus 1 before we did anything else. Now, this next step is something that people mess up quite often. You see you have 3 times -3 to the 3rd power, then plus 1. Do not multiply that 3 times -3. The next step is exponents there. And the exponent belongs to the -3, which means that we're taking -3 and multiplying it times itself. So -3 times -3 times -3, which comes out to -27. And then we multiply it times 3, which is the 8a value, right? And then we add it to the 1. So just keep in mind, this step is usually where people make a mistake. All right, make sure that the exponent only belongs to the parentheses that it's, surrounding. All right, and then also the other quick tip is that you'll be able to use a calculator. All right, so for most of the functions, you'll be able to plug it into the calculator exactly the way that you write it. All right, notice that there's a negative button and a subtraction button. It's important that you use them in the right order. So this first one, it's -2. Right? So we're going to use this one right here. And then this second one is -1, so we had to use the subtraction. If you don't use that, you may get an error. But in the grand scheme of things, you'll notice that if you plug it in correctly, the calculator will yield the right answer. Okay, so let's try a couple. In this next equation, I'm going to take -2 and plug it into this equation here. So my first step is I'm going to rewrite this with a box in there for x. People can use, you could use parentheses if you want to. And I'm going to take the -2 and I'm going to write it in everywhere I see a box. Then I'm going to use PEMDAS. So parentheses first. -2 plus 1 is -1. And then again, be careful here. The -1 is what's being squared. So -1 times -1 is +1, right? So this becomes 3 times 1 minus 1. 3 times 1 is 3 minus 1 equals 2. So f of -2 equals 2. You can also plug that into your calculator and you should be getting 2 as your final answer. So I'm showing you how to go through all of these steps here because for number 2, for instance, you're not going to be able to use the calculator necessarily. So it's important to know order of operations, but all that will be expected from you on the exam is to be able to show me this step and to get me what the final answer is. Okay, similarly, I'm going to write out the next one. So everything's the same except for instead of plugging in a -2, now I'm going to plug in a -1. Simplify the parentheses first. So -1 plus 1 is 0. 0 squared is 0, because 0 times 0 is 0. 3 times 0 is 0, minus 1 is equal to -1. So that's the way that works, okay? Taking a look at the last one, same idea here. except for now, instead of plugging in the -1, I'm going to plug in 0 for x. Simplifying that out, 0 plus 1 is 1. Again, 1 is being squared, so 1 times 1 is 1. 3 times 1 is 3 minus 1 is equal to 2. So f of 0 is equal to 2. Now, looking back, the special point, remember, looking at this from family of functions, we have that it's a parabola, it's a quadratic, right? So that means it's a vertex. And if I'm identifying a, h, and k, my a is equal to 3. My h is opposite of the inside, so it's -1. And my k is also -1, keeping it as it is on the outside. So remember that my special point is h comma k, which means that it's going to be -1 comma -1. And if you look at part B, we have f of -1, which is our x, right? And then is equal to -1, which is our y value. So notice, yes, it does work, even without the tricks of what we learned in the last function. Anticipating what this graph will look like, with an a of 3, we know that it's increasing. So it's going to be a smile, right? It's going to be facing upward. And also the 3 tells us that it's going to be vertically stretched. So it's going to be narrow or stretched skinny, right? Okay. And then lastly, we have the vertex, right? So we know that it is going to be shifted 1 left and down 1. Sorry about that. All right, so there's my horizontal and vertical shift. Now, in this next part, just be careful with the absolute value. A lot of times this will cause some errors. So be careful. Absolute value, remember that if I have the absolute value of -2, it's equal to +2. If I have the absolute value of 2, it's also equal to 2. So just keep that in mind. Remember what absolute value does for you. So now in this part, again, I'm going to do the same thing. And I'm going to put a box where I see the x, and I'm going to plug in a -1. Now, something that's super important, the absolute value bars act like parentheses. So we treat them just like parentheses, and we don't simplify that absolute value until we're done with it and it's all simplified in there. So my first step is going to be to simplify this piece. So -1 minus 2 is -3. Now, in this step, I have to simplify the absolute value of -3. We are not multiplying this negative times this negative or anything like that. That's not the way that it works. Remember, it's parentheses, then exponents, then multiplication. All right? So the absolute value of -3 is +3. Be careful. This is really tricky. So then we have negative times 3, which is -3. Plus 1, which is equal to -2. So g of -1 is equal to -2. Okay, so now try B and C on your own, and when you're finished, I'll show you the solutions pretty quickly. When you feel like you're ready to check the answers to B and C, press play. Okay, now take a quick second to see if your answers came out to be the same for parts B and C. So for part B, I got that g of 2 is equal to +1, and for part C, I got g of 4 is equal to -1. So now going back, again, we're going to take a look at the special point, right? In this equation, we have that our a is equal to -1, our h is equal to +2, and our k is equal to +1. My special point for an absolute value function is also called a vertex, and we find that with h comma k. So in this instance, our h was +2 and our k was +1. So my special point here was 2, 1. And again, notice in part B, we had g of 2 is equal to 1. So that was the same idea there. We were plugging in that special point for part B. Now we're going to describe the function in our own words. So my a value was -1. Which meant that it was decreasing. It didn't have any sort of stretch, so it wasn't particularly skinny or wide. All right. My h value was +2, which meant it was shifted right 2, and my k value was 1, which meant it was shifted up 1 from the parent function. Okay, so now what we're going to do is take a look at identifying the special point of the following functions. This is just a review from the previous lesson, so take a second and try to see that if you get the answers correct. Okay, take a second and see if you have any questions regarding those. So I just went quickly over it. Some really key things to remember here is that when there's no parentheses, h is 0. All right. Really, with the special point, it's just h comma k. So understanding what those special points look like for each family is also really important. All right, so the general shape always helps because you always want to make sure in the end of plotting these exact graphs that the graph looks the way that you would have interpreted or predicted it to look like in the previous unit. With linear, remember that h is always 0. There is no horizontal shift. You may have written NA, but remember, basically, there is none, so it's 0, and that's a y-intercept. And then quadratic here, there was nothing really particularly special here. Just -1, -4 was my vertex. Okay, so taking a look, we're going to do an example of plotting exact graphs. So this is putting everything from what we just went over into one, and it's making it nice and easy for us. So taking a look at this equation here, we are going to start with the A, H, and K. I see that there's an A of +2. H is opposite of the inside, so it's +1. And I don't see any K hanging out over here, so it's 0. So what this means in terms of a transformation is that it's increasing and opening upwards. And also we have a vertical stretch. So thinking about what that looks like you stretch a rubber band, right? It's going to be tall and skinny. All right. My H is +1, which means I'm moving to the right one. And then there is no vertical shift because K is 0. Now this seems to be that it is an absolute value function because the absolute value bars are around the X. The name of the special point for an absolute value equation is called a vertex, and the coordinate is h comma k, which is 1, 0. So now what we're going to do is plot the exact points of these, but we can anticipate that it should be a tall, skinny graph, with a horizontal shift of 1. All right, and it should be a V shape since it's absolute value. So now let's do a little bit of work and see if that's what comes out. So the next step is to identify the special point and write the values in the middle. So we already said that our special point was 1, 0. And we don't have to show any work for that one. Just like in the previous examples where I asked you to plug it in and it turned out to be the special point, that's always going to be the case. That's the pattern. So that's a freebie. All you have to do is write your x, y, and you're golden there. So that came from my h, k, my special point, which was 1, 0. All right, so you could just put the 1 in for x and the 0 in for y. Now, the next step is to pick one x value that is more than h, so more than this value. 1 more than 1 is 2, and then one that is less than h. So 1 less than 1 is 0. And then what we're going to do is plug those values in. Now, if you need a little bit more room, feel free to go into the margin here. There's plenty of paper, so there's no need to make it complicated. All right, and just like before, we're going to simplify that out, right? So we have the absolute value of 0 minus 1. So 0 minus 1 is -1. The absolute value of -1 is +1, and 2 times 1 is 2. So my coordinate here is going to be 0, 2. Okay, taking a look at the next one, I'm just going to do the same thing, except for I'm going to put a 2 in the box. Simplify on the inside there, so 2 minus 1 is 1. The absolute value of 1 is 1, and 2 times 1 is 2. So that gives me 2, 2. So now I have 3 coordinates that I'm going to plot. And again, it should be an absolute value that seems to be a little skinnier than the parent graph. So I'm going to plot the points 0, 2, 1, 0, and 2, 2. Taking a look here, it does appear to be a skinny graph that is vertically stretched, and it is a V shape because it's the same on both sides. And that's basically it. That's all you have to do here. And so now we have an exact graph. Your last step is just to make sure that your graph matches your description in step one. So again, we have an absolute value function. So it's V-shaped. It's increasing. It's stretched vertically, meaning tall and skinny. And it is shifted 1 to the right. See how it's shifted 1 to the right. So that means that, yes, it is. So my graph is good to go. So now for this next part, I want you to identify the special point h, k and fill in the remaining values for the input-output table. So this is basically what we just did, except for I don't need you to graph it in this step. So I'll do the first one with you. My A is -1, my H is +4, and my K is -2. So opposite of the inside, right? Keep it as it is on the outside. My special point is h, k, so 4, -2. I'm going to plug that in right here. Woohoo! All right, that is a nice freebie. We like that. We're going to pick one x value that's less than h, which is 3, and one that is more than h, which is 5. So now what I'm going to do is plug in 3. Simplifying it, 3 minus 4 is negative 1. Negative 1 squared is positive 1. Negative times 1 is negative 1, and that gives me negative 3. And then I'm going to do the same thing here, and I want to plug in 5. And simplifying that gives me here, so 1 squared is 1. Negative times 1 is negative 1, minus 2 is negative 3. Okay, so now pause the video and try the U-try for numbers 2 and 3. When you feel like you're ready, press play and check your answers. Okay, so just quickly check your answers. I didn't write out all of the work, but I'll be looking for that in your guided notes packet. So be sure that you write out all the work. Make sure that your answers match mine. Okay, so in this practice, you're going to basically do what we just did in the example, taking a little bit of what we did in this part and just plotting the coordinates afterwards. Now remember, I'm not asking you to write out your prediction, but you always want to make sure that your prediction matches what you're asked to do. So I'd like you to complete the last 4 questions, and we'll review them for the Do Now next class. If you feel like you have any questions or things that you're not sure of, please star them so that we can address them in the next class. Thank you, and hope you enjoyed the video.